Hello everyone, what's up? Today I want to show you a very simple way to compute the integral of secant. So this may seem kind of hard to approach at first, but there's a really nice approach in which you don't even have to integrate to find the integral of secant x, okay? So we need two facts, first of all. We need to know the derivative of tangent and the derivative of secant, okay? So I'm going to write them out here. We know that if we take the derivative of secant x, well, what do we get? We know this is going to be secant x times tangent x, okay? Now, the derivative of tangent is also very similar, and we're going to use that, that equivalence, or how similar they are, to build an expression that is going to be helpful for rewriting secant into another function, okay? So the derivative of tangent we know is going to be secant squared x, okay? Now, hopefully you can notice something here. You have secant x and secant squared x here. You can build the following expression. You can say that, well, what happens if you add up both of these functions, tangent and secant, and you differentiate them? So what is the derivative of tangent x plus secant x? You know that you can just differentiate each term, and we're going to get this expression on the other side. Now, I will factor out, should I write it out? Yeah, I will actually. We know we're going to get on the other side secant squared plus secant x times tangent x, okay? Now, what I will do here is I will factor out a secant x, okay? And then we're going to get the following. We're going to have secant x plus tangent x, okay? Now, you may wonder, well, why did I factor out? There is something very nice here. Notice that over here we have that the derivative of tangent x plus secant x is equal to secant x times secant x plus tangent x. Now, do you see the resemblance between secant x plus tangent x and tangent x plus secant x? These are the exact same term. In this case, we're just differentiating. On the left-hand side, we're differentiating, and on the right-hand side, we just have the plain expression. Now, this is helpful because we can do the following. Using these couple equations, we can say that, well, we know that. So here, I'm going to do semicolon. We know that using this, we can divide both sides of this equation by secant x plus tangent x, and we're going to get the following. We're going to have that secant x is going to be equal to, I'm going to write tangent first, yeah, so secant x is going to be equal to tangent x plus secant x differentiated divided by, so this is going to be this term down here, and now I am moving this factor to the bottom of the left hand side, so now we're going to have tangent x. Now I'm going to change the order. I'm going to write tangent first just so that it looks nice. Tangent x plus secant x. Now take a very hard look at this expression. If we use, a substitution, if we introduce a dummy variable, we could say the following. U prime is going to be, u prime divided by u is going to be equal to secant x. Now, what is this? U prime divided by u, well, you know that will be equal to the derivative of ln of u, okay? So this is equal to the derivative of ln of u, okay? Now, here's what we're going to do. Instead of integrating secant x, we're going to integrate an expression that is equal to secant x. We know that expression will be this, okay? So instead of integrating secant x, we're going to integrate this, okay? So let me write this. Let me write the following. So I'm going to make a little frame here just so that everything is, organized. So we're going to say the following. We're going to say that the integral of secant x dx will be equal to the integral of tangent x plus secant x divided by, and this is differentiated, divided by tangent x plus secant x dx, okay? Now, I could rewrite this integral using u notation, but then I would have to change dx, and it's really easy to notice that it doesn't matter what expression you have inside the parentheses. If you say that this function is a derivative, then the only result, or maybe not the only one, but the most obvious result for this integral needs to be the following. So do I want more space? No, I'm going to do it down here, yeah. Then this integral, based on this rule up here, so this expression has the same form as u prime divided by u is equal to the derivative of ln u. Now what does that mean? Well, if you integrate u prime divided by u, which is exactly the form that we're integrating here, then that means that you're integrating the derivative of ln u. Now you integrate, you differentiate, those operations, they cancel out, and you get ln u in the end. Now it doesn't matter what u is, okay? U could be any function, okay? And here, well, the function that we have is just simply u equals tangent x plus secant x, okay? And then we just get the result. Hopefully you already know this result, but now we'll use another way to compute it. We get the result of ln of, we write absolute value of secant x plus tangent x plus c. This expression turns out to be equal to the integral, the antiderivative of secant x, okay? Now give it a shot, differentiate this, and you're gonna get back to secant x, okay? So I think this reasoning, u prime divided by u, that form, that structure, using that structure to compute the integral of secant x is really fun. It's really nice. I really enjoy it, and yeah, hopefully you just learned how to use this reasoning to compute this integral, okay? I'm pretty sure there may be some other integrals you can do using this idea, this approach of, okay, let's find a structure of a derivative, and then let's integrate. Really, what you're doing is you're integrating a function that's being differentiated. You're integrating ln u but prime, and integration, differentiation, they will cancel out. And then if you have any function instead of secant x, if you can rewrite any function in terms of a derivative like this, you can integrate. For integrating this arbitrary function, you can just integrate this derivative. And then you will get whatever is inside the derivative or the parentheses, okay? That's a very nice approach for integrals, okay? And I think it's really, and secant is a really nice example of how you can use it, okay? So yeah, that's been the third video. Hopefully you enjoyed it, and see you in the following one. Bye.